can't wait to go home next week. But I should probably check the weather to see what I need to pack first, huh?
Today's unusually warm for this time of year, with a high of 20 and a low of -10, with a wind chill of -15. Overnight we're expecting 4 to 6 inches of snow, so dress warm.
That's cold. I don't know how you can survive in that weather.
I'm used to it. I mean, it can't get any colder than that, right?
What's cooler than being cold? Ice cold.
But again, -10 isn't as cold as it can get.
What's colder than that?
Your heart?
Well, yes, but no. Colder than -10 degrees Fahrenheit is absolute zero.
Absolute zero?
Well, yes, absolute zero is the coldest possible temperature that can be reached.
But to understand absolute zero, we must first ask ourselves, what is temperature?
The surface of the sun is 5,777 degrees Kelvin, and its core is 15 million degrees Celsius.
Whoa. Slow down. Kelvin? Celsius?
On Earth, we use the Kelvin and Celsius scales to measure temperature in science. We convert Fahrenheit to Celsius by subtracting by 32, multiplying by 5, and dividing by 9.
To get to Kelvin, we simply add 273 degrees Celsius to the temperature, and that's all there is to it.
Temperature is about the movement of molecules, about how fast these particles are going.
Imagine you're a molecule, and let's say you're at the school dance. As you're dancing the night away, the room gets really hot. That's because you're bouncing and moving across the dance floor rapidly.
Eventually, you will also get tired and run out of energy. When all the molecules, all of you, start slowing down, the room gets cooler.
What happens if the molecules eventually stop dancing?
Well, you see, we scientists have thought about that forever. And that's absolute zero.
Absolute zero is defined to be -273.15 degrees Celsius, or 0 degree Kelvin.
But just how cold is that?
Absolute zero is colder than the coldest natural place on Earth, Antarctica.
Wait. Coldest natural place on Earth? Is there somewhere colder?
Yes, in space, the coldest known place is the Boomerang Nebula, with a temperature of 1 degree Kelvin.
We scientists can do better than that. Just 15 years ago, we were able to cool a gas to below 1 nanokelvin, which is really small.
In a lab, it took the atom half a minute to move 1 inch.
To get a sense of speed, an air molecule travels at about 298 meters per second.
More than 10,000 times faster than an atom at absolute zero.
Wait, I get it now. So absolute zero is when molecules are barely moving.
So less energy is being generated, making the environment colder.
Precisely. You've hit the nail on the head.
I guess I'm not gonna pack too heavy since it won't be colder than absolute zero.